Hi guys, good morning. Welcome back to the new video. And oh god, this problem is pretty simple. Not sure that. See, it's a very simple, straightforward DP problem. That's it. Cool. Let's quickly jump on the intuition. Everything you will see very in detail. You will see from example itself. It will be very clear that what's going to be applied, how it's going to be applied, and what I have to do. Cool. Let's quickly go through the problem statement. Please read the problem statement carefully always, and also read the examples carefully, because the 80% intuition you will get from the problem statement and examples itself. So it's saying that we are having an array of distinct positive integers locations where we have locations of I representing the position of a city I. So basically the city I has this location at location I. Cool. I'm also having an integers as start, finish and fuel. So it's just a start location and finish location, and also the fuel I have. Right, at each step, if I am at city I can pick any city J such that it should be a different city, which means I and J should not be equal, and also J can be any cities in my entire city, which means I have the location array, so I can choose any location different than of the city I and move to that city J. If I choose the city J. Now, moving from the city I to city J, it reduces the amount of fuel, because for sure you are traveling some distance, and which means you are traveling from this location to another location. So what's the distance between these two locations? It is absolute difference between location I and location J. So that much amount of fuel will be reduced from your actual fuel which you have if you travel from city I to city J. Cool. Now, it is say that, okay, please notice the mod x, which is for sure if you go from location 2 to location 3, or from location 3 to location 2, still the distance will be 1, right? Cool. Now the fuel cannot become negative at any point of time, which means as soon as the fuel reaches 0, you have to stop, or as soon as your fuel reaches negative, you have to stop. See, it will also be a very important condition. That's the reason everything, this ABS thing is very important. This having, okay, you have to not choose an I equal to I and J same. It is very important. So everything we see will be important. So please make sure that you see what is important, what is not. Cool. The fuel cannot become negative at any point of time. Cool. And we are allowed to visit any cities more than once. It is also a very important condition. I am allowed to visit same city again and again, which means even if I have reached the finish, still I can continue going on to other cities and maybe reach finish again. That's also a valid path. So basically, if you just say, okay, Aryan, I started from the start, then go on to any path and then reach the finish, it's a one path. But then let's say I just again start from the finish, again I'm moving on and again reach the finish, then also it is also one path. That's the reason I can visit same city more than once. So please make sure that, okay, you can't, even if you have reached the finish, you can't stop. You still have to try something else also, that because it can happen that you can again reach the finish. That's the reason I said reading the question itself is very important. Fuel, it's just the condition of fuel. Okay, as soon as your fuel is finished, which means as soon as the fuel has gone less than equal to 0, then for sure you have to stop. Now, you have to return the amount of all the possible routes from start to finish. As I said, okay, it's one route, it is also another route. So here you will see I have two routes. So basically I just have to find all the possible routes from start to finish, which means I know I have to start from the start, and then ultimately my aim is, okay, I can reach this finish with this fuel as my fuel or not, which means until my fuel is more, and by that fuel whatever I have, I can reach that finish or not. Since that's again pretty large, so please do a modulo 100%. Whenever you have to do a modulo, it's good and safe to do modulo at every step, which means even if you do a add, do a plus b mod n, or if you think, okay, you are calling a DFS function, then you can have a plus b DFS mod of this particular mod, and then again a mod. So it is like that. Okay, you can just simply do a mod at every step. It's just a simple basic maths, right? Now let's come to the example itself. Now my main task, what was my main task? My main task was to simply start from this location start, right? Let's choose another color. Let's choose pink. Start from the start. Use this fuel and try all possible locations. Provided, okay, if I'm starting from the index 1, and see, start is the city and their corresponding locations are in the location array. So for sure, if I have locations as 0, 1, 2, 3, so 0, 1, 2, 3 are the city indexes and their corresponding locations are their locations. So I have to start from 1. I have the fuel as 5 and I can try on all the possibilities, which means I can go from city 1 to city 0. City 1, I can go to city 0, city 2, city 3, city 4. And also, I have, and see, what I'm considering about is, okay, I have my start, I have my finish, I have my fuel. But right now when I'm starting, okay, I have a car, I'm starting. So I'm only concerned about, okay, I'm starting and where I have to go next. Next, I have to try out is any other different city, which is 0, 2, 3, and 4. But provided I can try out that city if I have a fuel. So when I'm starting out, my mind is, okay, I'm starting from this location, which is 1, and why I need the 1 location as starting? Because for sure, I know I can't visit 1 also. If I'm starting from 1, I can't visit a 1. So it's the reason I know, okay, I want to know my starting location from where I'm starting because I can't visit that same location 1. And apart from this, I can visit all the other locations. But can I blindly visit all other locations? No, I cannot. Why? Maybe that distance between me and the location I'm going to travel is very much and I cannot travel with that fuel. So for sure, my fuel also will come in picture. Okay, I will have a fuel as 5. So for sure, I know if I travel the city 0, okay, from city 1, I'm traveling the city 0. It is 3, it is 2. So the distance is 1. So for sure, my 1 fuel will be used. So remaining fuel will be 4. Cool. If I travel to city 2 from city 1, I travel to city 2. So city 1 to city 2, the distance is 3. So fuel use will be 3. Remaining fuel will be 2. Then from city 1, I travel to city 3. The distance is 5. So fuel use will be 5. Oh, my fuel remaining is 0. Cool. No worries. And then I will just go on and for sure, okay. At this point of time, I saw, oh, 1 minute. I have reached my finish. So I can add a 1. I can still go and try, but I can add a 1 now. I can still go and try and I can add, but still I can add a 1 now. Why I can still go and try? What if this fuel remaining would have been a 1? This fuel remaining would have been a 1. So I would have still gone and tried something else. Maybe, let's say the fuel remaining is 3. Although I have reached the final state, but still, okay, 1 path I have found. So I will add in my answer 1, but still I can go and try some other states also. So I will still go and try. So basically, reaching the finish state is not I have to stop. Is not the condition that I have to stop. I can still try on. But here you saw, okay, it has reached 0, or as it reached less than 0, you can simply return a 0 or like simply stop, as what I'm saying. Now, I have to try other states also. So from 1, I tried to 4. If I try the 4, then for sure from 1, I tried the 4. 3, 4, distance is 1. So for sure, one fuel will be used. Remaining fuel is 4. Now for sure, I am at the new starting location as 0. My remaining fuel is 4. Now Aryan, why not you considered finish as one of your parameters? Because if you are starting from a location, okay, you want your start location, you want the fuel you have, and you also want the end location. Yeah, I want the end location too, but that end, won't it always be same? Won't it always be 3? Because I'm always concerned because my end is always same. My hops, my new starts can change, but my new end will never be there, right? End will always be 3. So for sure, this 3 I am concerned about, but it is something which is same. This location is something which is same. The thing which is changing for me is, okay, start and fuel. That is the reason, okay, I'm starting, bro, see, what you will do is you will start, okay, I need a start, I need a finish, I need a fuel. Then you will try to go on to multiple states. Then you will realize, okay, the finish is never changing. So, okay, finish, I don't want as such. I want start, I want fuel. Now, okay, I just went on to my new start, which is 0. New fuel remaining is 4. Again, from 0, I can try going 1, I can try going 2, I can try going 3, I can try going 4. Now, you can try, although you can try multiple stuffs and then you can build your entire tree by yourself. But I just showed you one thing. Okay, ultimately if what you will see, okay, from 0 you will try to reach a 3. See, although you have to make an entire tree, I didn't make it because it would become a bit longer, and in contrast also you have to think like that. Okay, shall I go and build an entire tree itself? No, it's not required. Simply you go and see, okay, 0 to 3, the distance is 6, my fuel remaining was 4, so for sure it will have a -2. So for sure, that won't give me an answer from 0 to 3. But yeah, it can have a different path altogether, which can give you a short answer. So for sure, you have to try the entire path. Although I didn't draw it because for sure I knew the answer is not going to match. So basically, I'm just trying from the looking at the example itself. I'm trying to build my own example in the tree form. Because I know, okay, it's the start, is the fuel. I'm not, okay, I'm not saying, okay, I'm blindly removing my eyes from this and now I'm making this. No. I am taking help of this to actually make my example much faster and stronger. Cool. Now, okay, this part is done. Now I am at location 2. My new fuel remaining is 2. So again, I can try multiple locations. From 2, I can go to 1, I can go to 0, I can go to 3, I can go to 4. Now, as from 2, I go to different locations. So for sure, what will happen is you can try and go to 3 also. From 2, you can try to go to 3. Fuel distance is 2, fuel remaining was 2, so okay, as you go on the fuel remaining will be 0. Oh, you have also reached the finish. For sure, one more answer is added. Okay, one answer is added from here. Now for sure, 3, one answer was added from here also. Now as you know, okay, you have 4 and 4, so again from 4 you will try on every possible locations, 0, 1, 2 and 3. As you try on and see every possible locations, still you will have, okay, 0, 1, and I'll just quickly jump on to main one, which is 2. So as you can go from 4 to 3, the distance used is 4. So remaining distance, see, although in this example, it is for sure saying, okay, the fuel remaining is 0. But please, don't blindly go and just write a condition that, okay, if the fuel is 0, then I have got the answer as 1. Now, if you have got the finish as same, then your answer is incremented by 1. And when your fuel has got negative, then you can say, okay, you have to stop. So please read the questions. That's what I said. Questions and example both parallelly can solve your problem. Cool. Now, if I have this 2, then from 4 I can go to 2 also. Cool. The distance is 2. So distance used is 2. Remaining fuel is 2. Now from 2 itself, you will again see. That is how you will solve. Okay, I am kind of building a recursion. I could see I am building a recursion tree, and I could also see the repeating sub problems. And even if you don't see a repeating sub problem, still you should be able to figure out, okay, I have a start, I have a fuel. There can be a same state occurring again also when I am going on and trying every possible start and fuel. So for sure, even if you can't make a tree, still by this recursion itself, you should be showing, okay, I have a start, I have a fuel. It can happen that I can have a same recursive calls to same pairs again. So please memorize that. So now you know, okay, you have a start, you have a fuel, you will try on from this start, you will try, let's say it is start. So you will try on every other possible starts, which is, let's say, I, which means if you're starting from this particular start, which is 1, so you will try out every other possible start, which is 0, 2, 3 and 4, which is every other I. And also you will see, okay, what is the corresponding fuel now after traveling from start to I. And that's how you can just simply build your recursion. And also make sure that, okay, now you know, okay, if you have reached the finish, please increment the answer by 1. If your fuel becomes negative, please stop at that moment only and simply return. When I say stop, you have to stop. Thinking what to return, we will see while writing the code itself. We will have a question mark and see what our code is returning, and correspondingly we will return what our code is returning. But please make sure that, okay, you have to stop if your fuel becomes negative. By the question itself, it is saying if the fuel becomes negative. Now, and you also know that, okay, you have to memorize it because for sure you have a repeating sub problem, right? Let's quickly jump on to what we have learned and what we have to do. We will have a start, we will have a fuel. Now, as we have to start, so we have to go to every possible locations I, as I showed you, every other possible location I. And when I say location I, What will happen if I go to location I from the location start? Simply the distance you have to travel, provided your distance, whatsoever you have to travel, it should be less than equal to fuel, then only you can actually travel that distance, right? And also if you travel that distance, which means if you travel to a location I, which means a city I having the location of I, then your new city will be, which means your new start will become that I itself, and also your remaining fuel will become fuel minus whatsoever distance you travel, which means from start you travel to I. So it will become your new distance which you traveled, so that will be used fuel. So new fuel remaining will be this fuel, existing fuel, which was here, minus this which you traveled from I to start, and your new start location will be I itself. That's your simple recursive condition which you have to write. And also as we showed, okay, if our start and finish are same, for sure I have got one good path, so please increment my answer by 1. And also please make sure that your fuel has been more than equal to 0, which means at any point of time if your fuel becomes less than equal to 0, simply return a 0. And why is 0? We will see that part, okay? But simply return, which means simply stop at that point itself. Cool. Now let's quickly see the recursion, and for sure we know that the memorization we have to apply. So we'll do a simple memorization, which is a 3-step memorization to simply solve this problem. Now as we have our main function, we will initialize our DP. We know our DP state is our start and the fuel. Start is nothing but the indexes. Indexes is simply the array indexes, which is from 0 to size -1. So for sure I initialize my start with the size itself. Fuel, it can be from 1 to the fuel itself entirely. So for sure array needs to be one more, so it's the reason I just do the fuel plus 1. Here it should be a size -1 plus 1, which will become a size. So that's the reason it's a size. Now I will simply call my recursive function, passing my locations array, which is static, passing my finish, which is static, passing my DP, which is kind of like we just pass in that. It will not change as such in the arguments itself. It's passed by address. Now start and fuel are the two variables which will be changed, and we saw how they will change. So as we go on to the recursive functions, our start and fuel, these will change. As we saw, okay, the base condition is if the fuel has become less than 0, simply return what? Return something. We will see what we are returning, but yeah, simply return something. Now I start calculating my answer itself. How? Simply, and see, when I say memorization, please write these 3 simple steps, which means before calling your recursive functions, please ask, have you found the same DP state? While returning, please say, okay, please put your answer in that DP state and also initialize that DP state. Cool. Now, as I initialize my answer, as I said, if I have anyhow reached my finish, please increment my answer by 1. But it doesn't mean that I have to return. I still, even if I have reached my start, even if I reach my finish, I still have to try for other possible locations. Okay, I tried for all the possible locations, provided I am trying for all the i's, but I will try for all the i's that, okay, I should not be equal to start, and also that distance should be less than equal to my fuel, because I said I can try some location I, provided, okay, it is not the same location as me, which means it is not the same location as start, and also it is not, it has the distance less than what fuel I have, like less than equal to. So if it is any of the case, which means if it is equal to start or the distance is more than my fuel, simply do a continue, which means you can't try this location at all. Simply continue. Cool. But if it is not, you can simply go and try for the new start. The new fuel will become, after subtracting the distance, it is a new fuel, and you can simply go and try that particular new location, and ultimately it will just go on, and if it reached the finish, it will simply increment your answer and it will just return and add that value, which means add a 1 in your answer itself. So it's the reason, okay, you are adding the number of paths. So if your fuel has become less than 0, so the number of paths will be nothing but 0. That's the reason I have to return a 0 here, because it will say, okay, I'm returning the number of paths, good paths, which means the paths finishing at finish line. If it is not the case, which means if the fuel has exceeded and I have still not found the good path, for sure, I have to simply return a 0, because no good path can be found now. That's the reason I have to, I know, okay, it is a good path I'm returning, number of good path I'm returning. That's the reason I returned a 0. And ultimately, simply do a mod at every step. I did a mod here. Cool. And now that this function will return your number of good paths ending at finish. right? And simply return that, and that would be it. Cool. The code for you for reference is down below. You can simply convert the code in Java or Python by simply using ChatGPT. Cool. The time, as you saw, that we had the DP state of n into fuel, so DP state, but for every DP state, which means for every of those calls, I am trying out for every possible locations, as you saw above. For every DP state, which means start and fuel, I'm trying for every possible locations inside. To go on to any possible location, that's the reason another n is added, and same will be the and that's for time complexity, and the same is for space, which means n into fuel, which is again the DP state. I hope that you guys got it. It was a very simple, very intuitive, very straightforward one, and nothing much complex than that. That's the reason I just said okay. It's very straightforward, although it's hard, but yeah, it's straightforward. So yeah, thanks for watching. Bye.